Look up at the night sky. It feels infinite. But it isn't, at least not to us. There is a limit to how far we can see in the universe. A boundary beyond which no telescope, no signal, and no technology can ever look. This boundary is called the observable universe. It's not an edge because the universe ends there. It has an edge because light hasn't had enough time to reach us since the universe began. Everything beyond it is hidden, not destroyed, not absent, just unreachable. So the real question isn't how big the universe is. It's this: what lies beyond what we can ever observe? To understand what's beyond the edge, we first need to understand what observable really means. The universe is about 13.8 billion years old. Light travels incredibly fast, but not infinitely fast. That means we can only see as far as light has been able to travel since the Big Bang. Now, you might think that means the universe is a sphere with a radius of 13.8 billion light years, but it's not that simple. Because space itself is expanding. The objects that sent that ancient light are now much, much farther away. So in every direction we look, the edge of the observable universe is about 46 billion light years away. That number alone feels absurd. But it's only the part of the universe whose light has had time to reach us. Beyond that distance, there are galaxies whose light will never, ever arrive here. No matter how long we wait, the universe isn't hiding them. Physics simply won't allow us to see them. It's important to clear up a common misconception. The observable universe does not end in a wall. There is no cosmic barrier, no physical edge. If you could magically teleport past that observable boundary, nothing dramatic would happen. Space would continue. Galaxies would continue. The laws of physics would continue. From that new location, you'd have your very own observable universe, a new sphere of sight centered on you. Every observer, anywhere in the cosmos, has their own horizon. There's no privileged viewpoint, no cosmic center, which means something truly unsettling. The universe we see is not the asterisk universe. It's just our patch of it, the part we're allowed to see. So what's out there? One possibility is simple and deeply uncomfortable. The universe may be infinite. Not just extremely large. Actually, literally infinite. If that's true, then beyond our observable bubble are endlessly more galaxies, endlessly more stars, and endlessly more planets. No edge, no boundary, no final frame. Infinity breaks our intuition. In an infinite universe, anything that can happen will happen. Somewhere beyond our horizon could be a galaxy almost identical to the Milky Way, a planet almost identical to Earth, even a version of you living a life almost identical to your own. Not because of science fiction, but because the sheer numbers of infinity make repetition mathematically unavoidable. This idea isn't proven, of course, but current measurements of the universe's geometry, which appears to be flat, are consistent with an infinite cosmos. And that alone should send a shiver down your spine. But what if it isn't infinite? There's another possibility. The universe may be finite, but far, far larger than what we can see. In this scenario, space is finite but unbounded, kind of like the surface of a sphere. You could travel in one direction forever without hitting an edge, and you would eventually loop back to where you started. In such a cosmos, distant regions could look statistically similar to ours. Same laws of physics, same basic structure of galaxies and voids. But they would be separated by distances so vast that no signal could ever cross between them. These regions wouldn't be parallel universes. They'd be part of the very same universe we're in, just forever causally disconnected from us. Reality would be continuous, but fragmented by the sheer scale of distance and cosmic expansion. We would be cosmic neighbors who can never, ever meet. Now let's enter even stranger territory. Some theories, particularly those related to cosmic inflation, suggest that beyond our observable universe, the very laws of physics might change. Imagine regions of space with different values for fundamental constants, different strengths for gravity or electromagnetism, different behaviors for matter and energy. In these alternate cosmic domains, stars might burn with a different light, or not at all. Atoms might form in unfamiliar ways. Complex life might be impossible, or perhaps even more inevitable. The theory of eternal inflation suggests our universe could be just one bubble in a much larger cosmic foam of bubble universes, each inflating and creating its own physical laws. We don't know if this is true. We have no way to test it. But the math allows it. And that possibility is enough to completely change how we think about our own existence. Here's the hardest truth of all. There are questions the universe may not let us answer. The regions beyond the observable universe aren't just far away. They are fundamentally, permanently unreachable. No faster ship, no future telescope, no clever scientific workaround can ever get us there. The expansion of space itself ensures that the light from those distant galaxies will never reach us. They are receding from us faster than the speed of light. This isn't a technological limit we can one day overcome. It's a physical one, woven into the fabric of space-time. This means the universe could be vastly larger, stranger, and more complex than anything we can ever confirm. Reality may always exceed our knowledge. So what does this all mean? The observable universe feels enormous, and it is. But it may be just a single tiny island in an ocean of reality that is unimaginably greater. Beyond what we can see, the universe doesn't stop. It simply continues without us. Not hostile, not even aware of us. Just vast. Perhaps the most unsettling idea isn't that we're insignificant. It's that we are surrounded by more reality than we will ever be allowed to know. And yet, from this tiny vantage point, we still manage to look up at the sky and ask the question, if the universe extends far beyond what we can observe, what does that mean for our understanding of reality itself? And if there are regions forever beyond our reach, does knowledge have an ultimate limit? Share your thoughts in the comments below. And in the next Mind Burst video, we will explore the oldest light in the universe, the cosmic microwave background, and what it tells us about the moment everything began. Thanks for watching.